Throughout the course of the semester, one word we'll be hearing over and over again will be the word domain. I would encourage you to think of the word domain as stuff okay for X. It's asking what is legal for us to use for X. Now, early in the semester, for us to figure out what's okay for us to use, there will be two questions that we should ask ourselves. The first thing, is there a fraction? We should never let 0 be on the bottom of a fraction because dividing by 0 is illegal. So the first thing to ask when thinking about domain, is there a fraction that I can get 0 on the bottom? The second question, is there a square root? When you are dealing with real numbers, you should never let a negative be up under a square root. So as we look about domain for the early part of the semester, the two things that will matter, is there a fraction? Is there a square root? Later in the semester, we're going to learn a third thing that will restrict domain. But for now, is there a fraction? Is there a square root? Let's look at some examples of finding the domain. For the first one, we're told a function 2x plus 1. Now, as you look at this and you're asked to find the domain, ask yourself, is there a fraction? There's no fraction there. Is there a square root? There's no square root. So as far as we know, there is nothing that restricts the domain. There is nothing that is a problem for X here. So as we write our domain, we always express domain in interval notation. You can put in anything that you want for X in this problem. You could put in negative a million. You could put in positive a million. Anything in between, you can put in anything that you want. The way that we express that in interval notation is to say from negative infinity to positive infinity, all real numbers will work for this problem. Remember that infinities get parentheses on both sides. How about this next one? This time the function that we're given is the square root of 2x plus 1. Right off the bat, you heard the key word, square root. The stuff that is up under that radical cannot be allowed to be negative. It has to be 0 or more. So whenever you've got the square root of some kind of stuff and you're trying to figure out what the domain is, take that stuff and make it greater than or equal to 0 and solve. For the problem we're looking at, 2x plus 1 greater than or equal to 0, that's the stuff that was under the radical. When I move the 1 across and divide by the 2, I have x is greater than or equal to negative 1/2. So our domain this time has to begin at negative 1/2 and it goes forever to infinity past that. Notice this time I've used a bracket because it's okay for negative 1/2 to be part of our domain. If you take negative 1/2 and put it in, 2 times negative 1/2 makes negative 1. Negative 1 plus 1 is 0. Square root of 0 is 0, and that was legal to do. So we've included negative 1/2, and we're going forever to the right past that. One last one here for us to think about. This one has a fraction. We can never let 0 be on the bottom of that fraction. So now let's take the bottom of the fraction and let's say, what's going to make that thing 0? If I solve this equation, I get negative 1/2 as the solution there, but that's actually the very thing that we cannot allow x to be. If x is negative 1/2, 2 times negative 1/2 is negative 1. Negative 1 plus 1 made 0 on the bottom of the fraction. So this is the value that x could never be. It can be anything else in the world, but it cannot be negative 1/2. To express this in interval notation, our domain starts at negative infinity and it goes up to negative 1/2, but we don't want to include that negative 1/2. Now we want to pick up there and get the rest of our number line, so we'll have to go from negative 1/2 to positive infinity. To join these two sections together, we'll take the union of the set. Looks like a U there that glues those two parts together. Notice that I've got parentheses with the 1/2 in both places because 1/2 is not legal for us to use. The domain is negative infinity to negative 1/2 united with negative 1/2 to infinity. Here's a tricky one for us to find the domain of. We've got 1 over the square root of 2x plus 1. This one has both problems. When you ask yourself our two key questions, is there a fraction? Yes. Is there a square root? Yes. So it's got both things that are problems for domain. If we just had the square root, we would take the stuff under the radical, make it greater than or equal to 0. But because this is in the bottom of a fraction, we can't let it equal 0. So for us to take into account both of the problems, let's take 2x plus 1, the stuff under the radical, but this time let's make it greater than 0, strictly greater than 0. I did not make it equal because if it's equal to 0, the bottom of the fraction will be 0. So I take just the stuff in the radical, strictly greater than 0, to account for nothing negative under the radical and no 0 in the bottom of a fraction. Solving this inequality, I end up with x is greater than negative 1/2. So our domain this time is from negative 1/2 to infinity. We know that infinity always gets parentheses, but why did I put a parenthesis here this time for the beginning of our interval? We used parentheses there because this was strictly greater than. It did not include negative 1/2. If we had, we would have had 0 on the bottom of the fraction.